Hi friends, welcome to another session on the operating systems. Now, continuing our discussions, let's get an introduction to the system calls. System call is the one with that requests programs to make the operating system kernel to perform privileged operations or access resources that are not directly available to the user program. The main purpose of the system call is to keep the important resources away from the users so that misuse or malfunctioning can be avoided, and the system calls will be acting like a bridge between the users or the user applications and the resources. The resources will be working in the kernel mode and the users are working in the user mode, and whenever the user wants to get the access of the resource that is precious, then it has to work in the kernel mode, and that's the work done by the system call. System calls are the interface between the process and the operating system. So let's just check how system call works. So this diagram is showing the user process is executing, and it is executing in the user mode, and whenever it wants to use some important resources, then it has to go into the kernel mode, and user don't have right to work in the kernel mode. Therefore, the user has to make use of what we call a system call, and the system call will get the thing into the kernel mode, and through system call only we can go into the kernel mode, and only in the kernel mode these resources are accessible. So to ensure safety and protection, system calls are very much useful. So the user program, user process, user application is working in the user mode and has no access to the resources, and the access, if it wants, then it has to go only through the system call, no other way out. So it makes use of the system call, and the system call goes and gets the permission to work in the kernel mode, and in the kernel mode only the resources are available. So uses the resources and comes out back to the user mode with the answer. So user might have asked a question. The question's answer may be available with the resources. So the resources are not accessible to the user. Therefore, user will ask the question through the system call. The system call carries the question down to the resources. The resources are working in the kernel mode. Only in the kernel mode resources are accessible. So it uses the resources, executes the call, and then gets the answer, and returns back to the user mode with the answer. So that's how the system calls are useful for accessing the important maybe files, resources, memory, whatever it is, which is of importance, and we don't want a user to corrupt it knowingly, unknowingly, because of ignorance or whatever be the reason. We don't want it to be corrupted, so we keep that aside, keep it safe from the user processes, and only through system call it will be accessed. And by ignorance, by negligence, by mistake, user cannot call a system call. So when a user is calling a system call, then the user knows what the user is doing. Therefore, by mistake, it cannot happen. Therefore, through the system calls, we assure the protection and the security of the resources. So that's another way. So from the user space, an application request for some information. So the application will request for a system call, and the system call will interrupt the process and switches from the user mode to the kernel mode. And once it gets into kernel mode, then the kernel mode identifies the system call, and if that system call is valid, then it is continued, and the kernel function based on the system call is executed, and then the system call returns the value that are output of the function of the kernel that is just executed, and then the return values are prepared, and these return values are sent back. And while sending back, again the execution context is switched from kernel mode back to the user mode, and then app continues to execute its earlier work, but now it has got the information what it was looking for. So it wanted some information, and that information is lying in the some resources, and those resources can be accessed only in the kernel mode because they are in the kernel space. So from the user space we have to go down to the kernel space, and that is possible only by switching the context from user mode operation to kernel mode operation, and that is done only by what we call a system call. This system call, once it switches the context from user mode to the kernel mode, then the system call is first identified and try to check what system call is wanting, and that particular operations are performed at the kernel level and the kernel mode. Because it is working in the kernel mode, the resources are available and it can extract the information, and this information is properly formulated and then sent back to the application. And while sending back, again the mode of operation is switched from kernel mode back to the user mode, and the user gets its answer and it continues its work. So this is the whole story behind the system call. So through this system calls, we keep the user applications away from the sensitive devices, sensitive resources, sensitive files and all that. So by mistake, user should not disturb our data, document and all that. So that's what system calls are meant for. Same thing is the APIs. So the user will request to the API. API will send the request to the server, and server will evaluate it and send back the answer, and that answer is sent back to the user. So it is the similar an example for that could be the API is one which is playing a role of a waiter here. So waiter interacts with the customers and gets the order, and then this order is forwarded to the kitchen, and the chef prepares the order, and the waiter gets the order back to the table and delivers to the table. So the interaction between the user and the chef is always done via the waiter. The customer cannot directly interact with the chef. So we have in between what we call waiter, and on similar grounds what we have is API. There are many system calls, many types of system calls depending on what type of functionality of the operating system we are using. So we can just look in this figure. There are totally five components of the operating systems: so file system, process control, memory management, interprocess communication, device management, and so on. Under each of them, we have multiple system calls. Say you want to work with the files, then without opening the file, it is not possible to use the file, whether it is to read or write or execute, whatever it is, we need to open the file. The file is there in the back end, and the file is a resource, and the user cannot directly interact with the file, because for interacting with the file, some protection is provided. The user needs some privileges. Only when the user has got a proper privilege, the file is allowed to access. So first process to do is to make sure to open the file. So while opening the file, the operating system or the file system component of the operating system will first verify whether the file is accessible to the user or not. If it is accessible, then it is allowed to open it. If it is not accessible, then error is raised. So once a file is opened, we can work with that, and at the end we should close it. We can you read the file, we can write onto the file, we can see some position in the file and all that. So these are some file system or system calls. Then getting into the process control, so we can create a process. So we can create a process. So we can create a duplicate of the process or a child process from a process which we use a system called fork. Fork is a wonderful system call we have in creating a process from one process. A process creates its own copy as another process. So the process which is creating a copy of its process is called a parent process, and the one just created is called a child process. So the process creates itself another copy. So this is done through the fork system call. If you want to execute any process, then exec is the system call we have. And when we want to wait for some event to occur, then our process has to wait. So for that we have wait system call. And once the process work is done, we need to exit. And if we don't want any other process to exist, then we can kill the other process and all that. So that's different process control system calls. On the same ground, we have system calls for memory management, inter-process communication, device management, and all that. So on this in detail, we are going to see in various modules in the coming sessions. So the next module we'll be looking at a process control, and then we look at memory management, and then we look at file management, and then disk management and all. So all these details we are going to see in various modules of the coming sessions. So that's a overview about a system call and the various types of system calls we can see in one place. Many details to come up. So please don't forget to like these videos, and please do subscribe to the channel, and have any queries, please do write in the comment box, and please share with your friends. Thank you.